so for the bending moment diagram, having continued our construction lines down, let's look back at the beam again a second. What we're saying, the first thing to note is that the bending moment is 0 at the supports. So at these two supports, A and B, here and here, we should find that the bending moment is 0. So it starts at 0, our bending moment diagram, and it ends at 0. And if it doesn't start at 0, or if it doesn't end at 0, because we can make it start at 0, if it doesn't end at 0, we know we've gone wrong somewhere. So that's the first thing. Now, if we look at this beam, what's happening is the change in moment over the change in length along the beam, dm by dx, so I'm now introducing this idea of calculus into the expression, is in fact the stress on the beam, And if I integrate both sides, I end up with the change in moment equal the integral of stress with respect to x. And as we see when we look at the calculus, this in fact turns out to be the area under the stress curve. So that's important. The calculus that I've done here is not so important as recognizing that what's the change in moment? It's the area under the stress curve. So if we go back to our stress curve, that's this area here. This area here gives me the change in moment between this point and this point. So what I do is I calculate this area. Let's rub out this green here. Equals 9.16, that's the height of it, it's a rectangle, multiplied by the base. Well, the base is from 0 to 3 meters, so times by 3. 9.16 times 3, 27.48, 27.48. So that figure is the change in moment as we go from 0 across to the 3 meter point. So we mark up here that moment, which is 27.48. And at this point, that's the moment. So it's going from 0 up to that point. And what happens is then is we say to ourselves, what is the gradient of this curve, dm by dx? This is the gradient. And that equals v. So what is the gradient of this curve? It's 9.16. Positive 9.16. So that means this line is going up at positive 9.16 that way. Now if we think about that, if it's going up at the rate of 9.16 gradient per meter, I'm going to end up at 3 lots of 9.16, which is 27. So in other words, what happens to the moment between here and here? That. Okay? That's telling me the moment is starting at 0, and as I go along the beam in this direction, the moment of the force is increasing until at this point it's 27.48. And then what happens is this area is then added on. So this moment now is the area underneath here, which is 1.16 times by the distance, which is 4. So 1.16 times 4, please. Sorry? 4.64. And so what happens now is I've got to add another 4.64 onto here. So this point. So that means what happens is I reach 32.12 at this point. So the moment increases, again at the rate of the stress, which is 1.16 for 4 meters. So 1.16 times 4 gets me up to this point. Do you remember us saying that this is the point of maximum bending moment? There's my maximum bending moment, 32.12 at this point. Now, what happens is I've now got an area underneath here, but that area is now negative, so it's reducing the moment. So this negative here, shear, minus 4.84 times 3 is minus 14.52. So that means I have to subtract 14.52 from the 32.12 to get 17.6. So that means my bending moment reduces. Again, the gradient, now look at the gradient. The gradient is the stress, which now is negative 14.52. So negative gradient should be coming down at the rate of 14.52 for 3 meters takes me to this point. So that point is 17.6. And then, finally, this area underneath here, 8.84 times by 2 is, and hopefully within a bit, because of course we're rounding as we go along here, that means the moment reduces by 17.6, and lo and behold, I end up back at 0 again. And again, what's the gradient at minus 8.84? Note the bending moment at this point here coincides with the 0 here where it cuts to. Okay? Now, if you think about it, that makes sense, because if as we were going left to right, the area under the curve here, this point and this point, these areas were increasing the moment. And these areas, because they're underneath, i.e. negative stresses, are decreasing the moment. If we start at 0 and end at 0, what can we say about the areas underneath the stress curve, above and below the line? They must be the same, yeah. The total moment on the left-hand side, the positive moment in other words, balances the anticlockwise, or the negative moment, which fits in with our understanding of what's going on and about moments. In a balanced situation, moments are balanced. That's what this is saying in a way. The area on the left of our maximum bending point must equal the area on the right, and that maximum bending, when it goes through 0, is shown on the bending moment diagram underneath. So this beam is experiencing a maximum bending moment of 32.12 kilonewtons, and that point at this point here. So we can say in this structure some interesting things about it. We can tell immediately by looking at the diagrams what are the values of the maximum stress here and here, and where is the maximum bending moment being exerted here, and what's the value of that maximum bending moment, so we can get information off it.